In the last lecture, we have discussed the types of samplings. In this lecture, I am going to discuss the sample mean, sample variance, population mean, population variance, and sampling distribution. Now, what is sample mean? We have taken the samples x1, x2 and so on xn are the random samples of size n. Then the sample mean is defined by the formula summation I equals to 1 to n xi by n. What is xi here? Xi's are the given random samples. So what is the word formula? Sum of all observations by number of observations. Here sum of all observations means x1 plus x2 plus and so on plus xn by number of observations are 1, 2, 3 and so on n. That's why small n. So sample mean is denoted by x bar. That is x bar equals to sum of all observations by number of observations n. Coming to the second definition, the sample variance. What is sample variance? Like as here x1, x2 and so on xn are the random sample of size n, then the sample variance is summation I equals to 1 to n xi minus x bar whole square by small n minus 1. So this is the formula for sample variance. So what are xi's here? Xi's are given random samples of size n, x1, x2 and so on xn. X bar is the mean value. So sample variance is denoted by s square. That is variance s square equals to summation I equals to 1 to n xi minus x bar whole square by n minus 1. This is the formula for sample variance. Now we have the note here. Population mean is denoted by mu and the population variance is denoted by sigma square. So like the above sample mean formula, the population mean is equals to sum of all observations in the population by number of observations. Similarly, population variance is summation I equals to 1 to n xi minus mu whole square by capital N, where capital N is the population size. So population mean is always denoted by mu, population variance is always denoted by sigma square. Here the sample mean is denoted by x bar and sample variance is denoted by s square. Okay, these are the sample mean, sample variance, population mean, population variance. Now sampling distribution. What is sampling distribution? Like as probability distribution, it has the formula, it has the definition, the set of values of the statistics so obtained to each sample. So the set of values of the statistics so obtained for each sample, or this definition is also can be written as the samples along with its statistics is called sampling distribution. So samples along with the statistics is known as sampling distribution. To understand this, we have, suppose if we draw a sample of size n from a given finite population capital N, then the total number of possible samples is given by NCN. So capital NC, small n. So we have NCR formula, n factorial by n minus r factorial into r factorial like this. It approaches to some constant value k. So for each k values means for each k samples we compute or we are going to find the statistics values. Those are mean, and variance. We can write the above information in tabular form also. The first column is sample number, means sample size. The second column is statistics. For the samples, we have statistics, mean and variance. By this formula, we have obtained case samples. So that's why in the first column, we write all case samples here. 1, 2, 3 and so on case samples. So in statistics column, statistics means mean and variance. That's why the column 2 again divided into two subcolumns, that is mean column and variance column. So for each sample we have the mean values like this, x1 bar, x2 bar and so on, xk bar. Similarly, the variance values are s1 square, s2 square, s3 square and so on, sk square. So this is the tabular form of the sampling distribution. Now we conclude that the set of values of the samples along with its mean and variance. So for the first sample, the mean value is x1 bar and variance value is s1 square. So the samples along with its mean and variance is represented as sampling distribution. This is sampling distribution definition.